One environment on Earth that might serve as a useful analog for the exploration of Europa's ocean, which is trapped beneath a pretty thick ice shell, is the Arctic. And so our team developed this under-ice rover to study these methane-rich lakes up along the Alaskan permafrost.
Here we're just taking an expedition out to a northern Arctic lake up near the northernmost point in Alaska. So we're driving on snow machines out to take our robot underneath the ice. Sub-zero temperatures, Arctic ice, biting winds, polar bears, and robots. God, I love this job.
The early testing we did tethered, which is our lifeline back to the surface. We didn't know whether this thing is going to sink or float, whether the systems were going to work. And so we're checking out the wheels, the cameras, the lights, just making sure everything works before we go wireless.
And if we do eventually deploy in a world like Europa, we're not going to have a tether. We're going to need to be able to do remote operations untethered.
Now we specifically go out there during times when the ice is thin to find out where these methane seeps are. I'm actually poking at the ice trying to find a trail for us that is safe for us to deploy the rover on.
Yeah, it's dangerous business walking around on this thin ice. I mean, this is why we thought of the rover to begin with. We thought, oh, well, just invert the surface. Instead of a rover that drives on the ground, we'll have a rover that drives on the ceiling. And what do we need to do that? We just make it buoyant. So it floats and essentially drives on the ceiling, which is the ice surface. Here's a good shot of a methane seep, where it's actually bubbling up from the lake floor and keeping the ice from freezing right there.
And the two different side lobes of the rover can be controlled independently. And so the cameras can look down at the lake bed and map out where some of the methane seeps are forming. And they can also be turned up to look at those methane bubbles and study what's actually happening at the ice-water interface.
And so the rover just drives right along upside down using buoyancy instead of weight, and gets up close and personal to be able to image and also sample these methane bubbles.
The later testing we've done untethered, so the rover is communicating through the ice back to a base station, and then from that base station up to satellites, back to operators at JPL or really anywhere in the world. This is about the closest you can get to Europa-like operations on Earth.
Our research up in the Arctic has this win-win where by studying the methane that's trapped in these lakes and coming out of the permafrost, we're helping to quantify the greenhouse gas emissions that are affecting climate change, while simultaneously building a vehicle and a scientific platform that serves as a precursor for something that may someday fly to Europa or Enceladus or one of the other moons that harbors an ocean.